Hello. Today's lesson is on section 8.6, the law of sines. The law of sines. You can use the following formulas to find the area of a triangle using two sides and an included angle. The area of a triangle is 1/2 the product of the lengths of two sides and the sine of their included angle. So the area is equal to 1/2 times B times C times the sine of A. B and C are on either side of the angle A. Area could equal 1/2 times A times C times the sine of B. Which is also equal to 1/2 times A times B times the sine of C. So the area of a triangle is 1/2 the product of the lengths of two sides and the sine of their included angle. Example 1A. Find the area of triangle ABC to the nearest tenth. In this triangle, B is equal to 6, C is equal to 3, and angle A is equal to 25 degrees. Okay, so we're going to use the area of the triangle is equal to 1/2 times 3 times 6 times the sine of 25 degrees. 3 times 6 times the sine of 25 degrees. The area of this triangle would be 3.8 square centimeters. Example 1B. We have 96, 36 degrees, and 48 degrees. So we're using this angle of 36 degrees and then the two sides. So the area of this triangle will equal 1/2 times 8 times 14 times the sine of 36. And that is equal to 32.92. Letter C. You are given A is 10, B is 15, and the angle is 55. So in this case, you have angle A is or area of the triangle is equal to 1/2 times 10 times 15 times the sine of 55 degrees. Letter C, the area would be 32.12 square meters. So the law of sines, you can find the area of a triangle using the law of sines. So far in this chapter, we have been solving for missing sides and angles of right triangles. In this section, we'll learn that the law of sines can be used to find missing parts of triangles that are not right triangles. So the law of sines states this: if the triangle ABC, if sides with lengths A, B, and C are opposite angles with measures A, B, and C, respectively, then the following is true. The sine of A, angle A, over the side A is equal to the sine of angle B over side B, which is equal to the sine of C over side C. So you can see how those are all related here. Side A is across from angle A, side B is across from angle B, and side C is across from angle C. You can use the law of sines to solve a triangle if you know either of the following. Angle, angle, side. Side is not between the two angles. Angle, side, angle. Side is between the two angles. Side, side, angle. The two that we're going to focus on will be angle, side, angle, and angle, angle, side. Side, side, angle, this one has several different cases, so we are not going to deal with this in this class. So the law of sines would state angle, angle, side has one solution, and angle, side, angle has one solution. Side, side, angle is an ambiguous case with multiple options. The law of sines can be solved to use to solve a triangle. Solving a triangle means finding the measures of all the angles and sides of a triangle. Today we're going to do example 2A, and tomorrow we will start with B. Okay, so we're just going to do A today, and the next video we'll have start with B. So we're going to solve this. We're basically going to find all the respective angle measures and the side lengths. Okay, so let's start with the degree of this angle B. Okay, so we can see that we have a triangle that we have 15 degrees plus 72 degrees, and that's equal to 87. So angle B will be 180 degrees minus 87. Which is 93. So angle B in this case is 93 degrees. Okay, so let's go ahead and lay out the law of sines. The sine of C. So I'm going to change colors here. So I'll go sine of C, which would be the sine of 72, divided by the side C will equal the sine of B over the side B. Okay, so the sine of C would be the sine of 72. Divided by, in this case, 375. Opposite of the angle 72 is the side 375. That is equal to the sine of B. The sine of B would be the sine of 93. Divided by side B, opposite of B, in this case, is what we're trying to find. Okay, so we're trying to find that side. Okay, so if we were to solve this, we'd have sine of 72 degrees times b is equal to 375 times the sine of 93 degrees. If I was to divide by sine of 72 on both sides, I will have myself b. So cross the 72, sine of 72. So side b will equal 393.76. So we found side B. We have all the angles. Now what we need is, we have side C already. It's given to us. Now we need to find side A. So we're going to use over here, I'll switch to back to black there. So I'll go sine C, oops, sine of C, angle C, divided by the side C is equal to the sine of A, sine of angle A, divided by little a. Okay, so the sine of C is the sine of 72. And we're going to divide that by C, which was given to us in the problem, 375. Angle A is 15 degrees. So sine of 15 degrees divided by A. So we have ourselves A times the sine of 72 is equal to 375 times the sine of 15. Now let's solve for A by dividing by sine of 72 on both sides. Okay, so on the left, the sines of 72 cancel each other out, and we have side A is equal to 375 times the sine of 15 degrees. All of that's divided by the sine of 72. So side A would be 102.1. 102.1. So by the law of sines, we can solve a triangle, basically find all of the measures of the angles and the side lengths. In the next video, we'll kick up with example 2B, which will be example 2B, then we'll do example 3 and 4, and that will be it for this section 8-6. Thank you. Have a great day.